sp³d hybridization. For example, molecule PCl5, first write the electronic configuration for all atoms in the compound. This is electronic configuration for P, and this is the electronic configuration of fluorine. Secondly, write the orbital diagram of the central atom of the compound. The central atom is phosphorus. Write only the orbital diagram for valence electron of the central atom. Note that atoms of period 3 and higher can expand because they have empty d orbitals. This phosphorus is in period 3, so it has empty d orbital. That's why it's in the exception octet rule. It is expanded octet. Write the orbital diagram for valence electron of the central atom. Ground state 3s2 3p3 and with 5 empty d orbital. And then promotion of electron. In order to determine the electron orbital diagram of promotion of electron, look at how many sigma bond or single bond does the central atom has. This phosphorus has 5 single bonds or 5 sigma bond, so it needs 5 unpaired electron. In the ground state, it has 3 unpaired electron. In promotion of electron, it needs 5 unpaired electron. So we have to take this one electron, the pair in 3s orbital, put in the empty 3d orbital, making 5 unpaired electron in total. And then mix all the orbitals, mix all the pure orbitals in promotion of electron to identify the type of hybridization. When you mix all these pure orbitals, it will become sp³d orbitals because you use 1 s orbital, 3 p orbital, and 1 d orbital. That's why the name is sp³d hybridization. We do hybridization for the central atom only. Next, the energy level diagram of sp³d hybridization. This is the ground state energy level diagram. 3s orbital has lower energy than 3p orbital, 3p orbital lower energy than 3d orbital. When you mix this 3s and 3p and this one electron unpaired put in the 3d orbital, mix them, it becomes sp³d hybridized p atom, the central atom. If you look at properly, the energy level of sp³d is slightly above 3p. This one, it's slightly above 3p because it's mixing sp and d. So sp³d energy level is slightly above 3p but below 3d, just slightly above. Not in the middle, not in between, just slightly above the 3p energy level diagram. And don't forget to include the empty 4 empty 3d orbital. 1s orbital involved mixed with 3p orbital and 1d orbital. When you put this electron unpaired into here, mix the pure d orbital, making 5 equivalent sp³d. So you have 1, 2, 3, 4, 5 sp³d orbitals in total. And this is how you draw the central atom hybridized for p atom. So you have 5. When you have 5 sp³d, look at the molecular shape. Okay, the molecular shape. If you look at the central atom P, it has 5 single bond. So 5 single bond, electron group 5. Electron group 5, electron group arrangement, trigonal bipyramidal. And you want to determine the molecular shape, look at the central atom, no lone pair electron, so the molecular shape is the same as electron group arrangement. So that's why you have to draw sp³d in trigonal bipyramidal. Make sure the angle between the plane, this 3, 1, 2, 3 plane is 120 degree, and the angle between above and below is 90 degree to the plane. And then Cl, you have to draw the orbital for Cl as we did before. the Cl, the unpaired electron of Cl involve 3p orbital. So that's why you have to draw 3p orbital of Cl overlap with sp³d, each sp³d of the phosphorus central atom. So this is the final hybridization of PCl5. Hybridization only involves the central atom. Next example, SF4. Write the electronic configuration for all atoms in the compound, and then you have to write the orbital diagram for valence electron of the central atom. Valence electron of central atom for S, 3s2, 3p4, so 2 electron in 2s, 4 electron in 3p. Make sure singly first before pairing up. And promotion of electron, look at how many sigma bond does S have. This S has 4 sigma bond or 4 single bond, so this central atom needs 4 unpaired electron. That's how you draw the electron in promotion of electron. Look at how many sigma bond. So 4 unpaired electron. In ground state, you only have 2 unpaired electron. So take the electron, the pair electron that has higher energy orbital. So you don't take this one, take this one from p orbital. Take 1 electron from p orbital, put into the 3d orbital, making promotion of electron 4 unpaired electron and 1 paired electron. This pair electron is for lone pair of S. So mix together all the electron, making sp³d orbital. 1 s orbital involved, 3p orbital involved, and 1d orbital involved. That's why the name is sp³d orbitals. And one of the sp³d orbital has paired electron because this compound has 1 lone pair. And again, if you want to draw the molecular shape, you have to calculate the electron group. The electron group is 5, 4 single bond plus 1 lone pair, 5 electron group. And then electron group arrangement, trigonal bipyramidal. But this central atom has lone pair, so the molecular shape is not trigonal bipyramidal. The molecular shape is seesaw. So seesaw, 1, 2, 3, 4, this seesaw, and then with 1 lone pair electron here. So only 4 F atoms overlap. Okay, if you draw the orbital diagram of F, the unpaired electron for fluorine involve 2p orbital. That's why for fluorine you have to draw 2p orbital, and then all 2p orbital for F overlap with each sp³d orbital. And make sure this S has 1 lone pair electron. This orbital does not overlap with any atom because it has lone pair electron. So this is the final drawing of SF4 hybridization.